So we just gave you a bunch of rules, but it turns out those are kind of considered to be the quote-unquote simpler ones. There's one rule that is kind of the hardest to use, uh, and that is the chain rule. Now don't be intimidated by it. The hardest to use doesn't mean it has to be hard, but the trouble is sometimes identifying when to use the chain rule. So the chain rule is for when we want to take the derivative of a composition of functions, right? Uh, and we actually often write the rule like with g on the outside. What, what did I just say? G as the outside function. So how this actually ends up happening is this goes to g prime of f of x times f prime of x. Another way to write this is dy dx, right? The derivative of the function y with respect to x is the derivative of y with respect to some new variable u times du dx. Well, how do those match and what do those mean for us? Well, let's say if I start out with um, my outside function y is g of f of x, so if I say y of x, then dy dx I can say is the derivative of y with respect to the function f times derivative of the function f with respect to x. And so what does this mean? Well, this means look at the outside function, right? Y is this big outside function here. Take the derivative of this, treating f as your variable, and that turns into the derivative of g with f as the inside part still, times the derivative of f with respect to x, well that's just f prime of x. So there's two notations to kind of get the same thing, but this one is so much easier to comprehend what's happening and what's going on and what to do. This one is kind of more useful in things when you get to like multivariate calculus, you know? And it turns out once we start doing like what's called integration down the line, then that way of writing the chain rule is going to be useful for us. But it turns out we really want the one up top. Okay, so let me erase everything but the rule at the very top. And then we're going to do a couple of examples together. Right, so this section is just all about the chain rule and how to use it. So kind of the hardest part about the chain rule is identifying what are the two functions involved, you know, that we have this composition with, and then doing the actual calculations of plugging that in. So let's say I have a function like x to the fourth minus 11 to the 20th power. So this is a composition, right? We are plugging x to the 4th minus 11 into the function x to the 20th. So what I mean by that, the outside function, what are we doing is we're raising some other function to the 20th. So we just write this as x to the 20th, right? What am I doing on the outside? Raising something to the 20th power. So something is what we call x, right? Well, then the inside part that we're just labeling f is going to be my inside function, just what am I doing on the inside here? X to the 4th minus 11. So now we find the derivative of both pieces. The derivative of x to the 20th, that 20 comes out front. 20 minus 1 is 19. And now derivative of f, the 4 comes out front. 4 minus 1 is 3. The derivative of this constant term, minus 11, disappears. It's 0, right? So it's gone. Okay. So this is supposed to be g prime of the original f, times f prime. So g prime is 20 times x to the 19th. So we plug in the original function, so x to the 4th minus 11 times f prime is 4x cubed. Okay, very good. That is how we use the chain rule. Now, there's some functions where instead of just one layer of the chain rule, there's going to be multiple layers. So let's say I have something like h of g of f. Well, if we want to take this derivative, recognize the outside layer is h, right? So you have h of x is the big outside function, and its derivative we would call h prime. Well, then the inside function is g of f of x. Well, now we want to take this derivative, but now we have to use the chain rule on this, right? And we know already from the previous thing, right, outside function is g, inside function is f, derivative of g, g prime, derivative of f is f prime. So we have g prime of f of x times f prime. Now, to find this derivative, it's derivative of the outside times the inside as is. So the big outside is h, and the inside from the start was g of f of x, times the derivative of the inside, derivative of g of f of x is g prime of f times f prime. So now we can see here why this might be called the chain rule. Because when we have this chain of functions, or this composition of functions, it kind of takes this derivative into a chain of these other derivatives. Okay, so first, in order to do this one, um, I realized the section before this is about trig functions, so this is kind of directly tells us which kind of functions this is really easy to see it with. So let's do sine of x. So this is absolutely a composition. So the outside function is sine of x. The inside function is sine of x. The derivative of sine is cosine. Well, the derivative of sine is still cosine. So taking this derivative of the outside is cosine. Leave the inside alone. Times the derivative of the inside. Oh, derivative of sine is cosine. Now, what if we up this a little bit and do derivative of sine of x squared? So now the outside function is sine of x. The inside function is sine of x squared. So now taking the derivative of the outside is still just cosine, but now the derivative of the inside requires its own chain rule. So now we look here, the outside is sine, the inside is x squared, derivative of sine is cosine, derivative of x squared, the 2 drops out front, and then we subtract 1 from the power, 2 minus 1 is 1. So this derivative is the derivative of the outside, cosine, of the original inside, times the derivative of the inside, 2x. So now with all of these pieces, we go back to the original and say derivative of the outside was our cosine, and then we put the original back in, and then multiply by the derivative of the inside, cosine of x squared times 2x. Very good. So this is These are three functions all composed together. And this is also an instance where we kind of unavoidably have to use the chain rule. So it turns out before, right, with this thing I wrote earlier, x to the fourth minus 11 to the 20th power, we can expand that out. Hypothetically, technically speaking, we can do it. Do we want to? Absolutely not. But you could, right? So in theory, you can get around using the chain rule sometimes. However, oftentimes, like with these functions, we could not get around using the chain rule. So, very good. Our functions can take on a few different forms that really, you know, sometimes they take on different forms that really change how we want to use this, In theory, this could be x to the 80th, dot, 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 but we don't want to do that. It's better to do it this way. So sometimes they can take on different forms, some of them easier to handle, but maybe worse to get to. And sometimes, like these, they don't really get to be written any differently that has us choose a different rule to use. Okay, very good. So this is the chain rule. Um, Another example, I'll do one more. Let's do the square root of tangent of x. Now the outside function that we keep, the rule calls it g of x, is the square root of x, which again, like we did for the power rule before, we like to write this as to the 1/2 power. And the next rule, or sorry, then we see the inside part we call f is tangent of x. So now the derivative of the outside is the derivative of x to the 1/2. So that's 1/2 x to the 1/2 minus 1. Well, 1/2 minus 1 is negative 1/2. And just like before, I can rewrite this as 1 over the square root of x. Well, now the derivative of tangent from our trig function gives us secant squared of x. So now plug those back into what we have up top. G prime is 1/2 1 over the square root of the original inside. Well, the original inside was tangent times the derivative of the inside, secant squared. Very nice. Yeah, we technically can like write that as a single fraction. We don't really need to though. So if you just care to see it, we could write this as this. But there's no meaningful way to simplify this. So very good. This is the chain rule. People like it the least oftentimes, but I promise it really isn't too bad. The hard part is identifying what the two functions are and keeping track of what to plug into what, which is just means show your work, be careful, and look at each step, right? So very good. This is the chain rule, or has been the chain rule. Thank you.